Welcome back to the next segment of Introduction to Operating Systems and Virtualization. My name is Scott Neal, and today we are talking about hypervisors, the virtualization component that puts the V in virtualization. So, because hypervisors are such an important component, I want to spend a little bit of time today discussing what a hypervisor is. We really want to talk about hypervisors at a very high level today. We're not going to sit down and break down, specific lines of code or anything like that. But you really should have an idea or a sense of what a hypervisor is and how it functions in the virtualization equation. So we're going to do that today. We're going to also talk about the two different types of hypervisors, the type 1 and the type 2 hypervisor, and we're going to differentiate between those two types in today's lecture. We'll take a moment to discuss a very brief history of the evolution of the hypervisor, as well as identifying the roles of a hypervisor in today's virtualization environments. And we are going to discuss, at the end of our lecture, we're going to look at different vendor products and how hypervisors are used in some of these products before we finish up. So, what is a hypervisor? Well, simply put, a hypervisor, whether I call it a virtual machine monitor or a virtual machine manager, really is essentially software that's going to allow me to abstract or isolate operating systems, and in some cases applications, from the host system's physical hardware. It is a variant from the term supervisor. We use the term supervisor traditionally to describe what a kernel is in a traditional operating system. And since the code for the hypervisor runs on top of and supersedes the operating system, we call it a hypervisor. Hypervisors can be responsible for negotiating or arbitrating the VM resources that are needed with that of the host, and it will provide the virtual operating system platform and manage the execution for the guest operating systems. So, depending on what type of hypervisor you're going to use, it will either have the ability to run directly off of the hardware itself, or it's going to sit as an application on top of the operating system. So how did hypervisors get started? How long have they been with us? Well, they've really been with us since the 1960s. IBM came out with the very first Type 1 hypervisor for the CP/CMS, really a predecessor of IBM's ZVMs, capable of running literally thousands of Linux VMs, which is really kind of a cool appliance. Hypervisors' main function was to create a sandbox on mainframes. And developers use those sandboxes so they could efficiently test operating system improvements in a fairly safe environment without worrying about disrupting the mainframe operations. Really, you didn't see a lot of change in hypervisors for 30 years. It wasn't until the 1990s when researchers started looking for ways to maximize the use of hardware resources that we saw a shift from hypervisors from the mainframe environment to the PC environment. And it was during this time, 1997, after several years of research and trying to figure out ways to implement this, that Virtual PC for Macintosh was released by a company called Connectix. It was kind of a big deal at the time. It wasn't long after Connectix got into the game that VMware came to be, and probably the most important, as far as the 1990s is concerned, as far as the important milestone that VMware accomplished, was creating the very first 32-bit virtualization product for consumption. In 2005, VMware released a free version of Workstation called Workstation Player, or Player as we knew it at the time. VMware Player allowed us as administrators, the ability to expose ourselves to virtualization, often for the very first time, begin to experiment with virtualization, and really begin to experiment with how virtualization can benefit our IT departments in our corporate settings. In 2008, DirectX for the first time ever was able to be enabled in Windows and Linux virtual machines using VMware's latest workstation product at the time, Workstation 6.5. So VMware has been around a long time in the virtualization game. Maybe not the first player, but one of the first players. And they have really adopted the first to market strategy, which has done them well throughout the years. Workstation Player, as I said before, really was a game changer because it really opened us up as administrators to the ability to, at a very low cost, begin to experiment virtualization and figure out how we can strategize effectively to use virtualization in our environments. Type 1 hypervisors are known as native or bare metal hypervisors. They run directly on the hardware without needing an operating system. So, much more efficient. The Type 1 hypervisors tend to be more secure and available because they're not having to talk through the operating system layer. They tend to be more stable as well. I don't have to worry about, for instance, if I do updates or upgrades to an operating system on a traditional operating system. If I'm running a Type 2 hypervisor, then that's going to necessitate a reboot of not only the operating system, but of the hypervisor, the VMs, and the whole shooting match. So Type 1 hypervisors tend to be more secure, more stable, more reliable, and certainly more efficient because we're not having to eat up the resources with the operating system, the traditional operating system, or talk through all that code through the operating system to get the hardware to do what we want it to do. Type 1 hypervisors, vendors that use it, Oracle for VM Server for Spark, Citrix Xen Server, Hyper-V, and VMware's ESX, ESXi all use a Type 1 hypervisor in today's environments. Type 2 hypervisor or a hosted hypervisor really runs on top of a conventional operating system platform like any other application. And as I just pointed out, if Type 1 hypervisors tend to be more efficient, more secure, more stable, why the Type 2 hypervisor? Well, the Type 2 hypervisor was really much quicker to get to market for PC users than trying to build a Type 1 hypervisor that could adapt to a wide variety of hardware platforms. So when you're building hypervisors for the very select few types of mainframes out there, that's one thing. When you're building hypervisors that are going to have to interact with a wide selection of hardware, it may be best to talk through the operating system and let the operating system do all the hard work. That's exactly what developers did. They came out with a Type 2 hypervisor that would run on top of an operating system and eliminate the need to take the guesswork out of all the different types of ways to communicate to the hardware by letting the operating system do it for it. So, environments that use Type 2 hypervisors include Workstation, Workstation Player, Oracle's VirtualBox, Parallels for Mac, QEMU, which is really a free open source hypervisor. These are all Type 2 hypervisors. They are used extensively in a lot of markets out there, and a lot of IT shops are using Type 2 hypervisors for testing, for doing development, and so on and so forth. Alright, role of a hypervisor. What makes a successful hypervisor is, if we go back to Popick and Goldberg's defined 3 characteristics of a successful virtualization, a good hypervisor should be able to provide an environment that's identical to the original physical environment, should be able to provide that environment with a very minimal performance hit to the product, and retain a complete control of the system resources. So that means really what we're doing with a hypervisor is we are tricking guest operating systems into believing it has full control over the physical hardware resources. By doing that, the hypervisor fools the guest operating system into believing this. The operating system in the virtual machine thinks that it has full control over what it perceives as the total hardware resources that are available to it. But in reality, we know that only a fraction of the host resources are being made available to that VM. And it's thanks to the hypervisor that that is possible, because it's negotiating the resources with the host operating system or by looking at the resources itself, and it is able to make those negotiations and decide how the operating system resources or the hardware resources are going to be divvied out to the virtual machines. So, like, I always like to use this analogy. You know, the old Jim Carrey's character in The Truman Show, right? The Truman Show was about a guy who, unknown to him, was part of this lifelong TV show. And this character, Jim Carrey's character, grew up thinking that he was living in the real world when in reality he was living on a giant TV set. So virtual machines are really kind of like the Jim Carrey character in The Truman Show. The virtual machine really has no idea that they are not running in a physical environment. They see the resources that the hypervisor wants them to see. They think they're running in a physical environment just fine, thanks to the hypervisor. All right, hypervisor, in addition to tricking the operating system, must be able to balance the workload of not only one VM, but all the guest VMs that are running in the environment. So if you have a finite amount of resources, and each guest is making independent requests for resources, believing the resources are in its complete control, then the hypervisor is going to have to act as an intermediary between each guest and the physical devices. It's going to be the decider on what priorities are given and what available host resources should be divvied out to each VM at any given moment in time. So that's essentially what a hypervisor does. So exactly what does this mean if we look at and break it down into vendor products? Well, if we look at, for instance, VMware's ESXi, or formerly ESX, it really was the first commercially available hypervisor. This actually came out in 1998, 99 for the 32-bit platform. Currently, it is the market leader in user share and the maturity of offerings. Its architecture is a Type 1 hypervisor architecture. It's not tied directly to an operating system. ESXi runs on a bare metal platform. This is unusual for VMware products. There are no other VMware products that run on using a Type 1 hypervisor. So a Linux kernel is going to be started and then first used to load a specialized virtualization components that run. The ESX version 4.1, there was a Linux console that came with ESX when it first came out. The console allowed the user the ability to manipulate the hypervisor environment, in a very nice GUI, easy to understand way. There were a couple reasons why we dropped that at version 4.1. One of the reasons was security. VMware thought that since they were using a Linux console being a very highly adopted console, that there would be people out there that would use that as a platform of exploitation into the hypervisor. So one of the reasons why they decided to get rid of it was because of security. The other reason why they decided to get rid of the console was because, quite honestly, it ate up a lot of resources. The hypervisor itself, I think, was something like, I don't know, 32 meg or 32 kilo. It was very small code that ran on the box. The console, on the other hand, was like 10 times bigger than the actual code that it was driving. So it was decided that for the sake of saving the resources and for security that they would drop the Linux console. Alright, another vendor, Citrix Xen, really began as a project at Cambridge University. It was first released in 2002 as an open source project. Xen, whether Red Hat, Novell, or Sun is using it, they all have added the Xen hypervisor to their products. Citrix actually acquired Xen in 2007. It too is a Type 1 hypervisor running on bare metal. But there is a difference with Xen over VMware's ESX because it's going to be using a special Linux-based guest which we call a DOM0 or domain 0. The purpose of it is that it boots at the same time that the hypervisor does, and it's going to retain the higher privileges than all the other guest VMs. It's going to actually be responsible for handling all of the input-output requests for the other guests. So if I go back and look at this particular diagram that deals with the Xen, you'll see that the console actually interfaces with DOM0 that we use as a management tool for the hypervisor. And then all of the VMs are going to talk to DOM0 as they make their requests for hardware resources. There are some vulnerabilities with Xen because the requests need to go through the DOM0. Anytime I do patching, it's going to require a restart, during which time all of the guests are going to go offline with DOM0. If I patch it, I have to bring it down for any reason, then there's no way for those boxes to talk to the hardware resources, so they go offline. The DOM0 is going to also utilize its own resources, so it's going to be taking away additional performance capabilities from the other guest systems as it manages those particular systems. So those are a couple of downsides to Xen. Hyper-V is kind of like Xen in some ways. It has a very similar architecture. It was released in 2008, but the virtualization, if you go all the way back, you can go all the way back to Virtual Server in 2005. Server 2008 really came with Hyper-V as a native feature, or native role, sorry. Server 2012 has Hyper-V. Server 2016 certainly has Hyper-V. And Windows 8.1 and Windows 10 both have Hyper-V as features that can be enabled on the box. As I said before, the architecture is very similar to Xen. Device drivers are part of the parent partition. So the parent partition is based on Microsoft Windows. It is Type 1 hypervisor, however. The virtualized workloads are called partitions. We don't call them guests. Don't know why, but that's what we call them. They're similar to Xen in the sense that the parent partition running Windows has direct access to the hardware layer, but all the other child partitions are going to be managed specifically by that parent partition. So because of this, because the architecture is similar to Xen, the vulnerabilities are going to be similar to Xen as well. Alright, other solutions that are out there. Red Hat's KVM. Initially Xen now has its own kernel-based KVM. Oracle Virtual Machine is Xen-based. There are other solutions that are available with the Sun acquisition. Many other commercial and free solutions are out there on the market. The market's still brand new. Really, when you talk about the evolution of markets, the virtualization market is still brand new. It's in its infancy. So you can expect new players to come any day now. Some will go away, and they're all going to be evolving quite quickly as we see virtualization become more and more prevalent in today's IT infrastructure. Alright, let's summarize. What's a hypervisor? It's really software. It's going to allow for multiple virtual instances to run simultaneously on some sort of physical hardware box. Serves as a go-between between the VMs and the host systems that they reside on. Two types of hypervisors. The Type 1 hypervisor runs directly on server hardware. The Type 2 hypervisor is going to run as an application sitting on top of an operating system. Examples of a Type 1 hypervisor would include Xen, Hyper-V, and ESX or ESXi. Type 2 hypervisors would include, Workstation, Workstation Player, Oracle VirtualBox, and so on. Both serve very integral, very important niches in the IT infrastructure. So don't think that one is better than the other and we should just never use the other. They both have a place in how we do things in IT. Hypervisors extract the hardware resources from the virtual machines they support. They're going to provide some sort of prioritization using some sort of algorithmic code, using configuration settings, using load balancing for all of these resources. And we're going to look at and show you over the next several weeks how we can manipulate hypervisors in some way to give us some power over how those resources utilized by multiple VMs. Virtualization, still an evolving market. Today's leaders would include VMware, Citrix, and Microsoft. And I think that pretty much covers it for Lesson 3. So, if you have any questions, let me know. We are going to be moving on to the next segment here shortly, and I look forward to seeing you later.